So I've had some questions about how to convert a truth table into a formula and vice versa. So the first thing I wanted to point out is that from week number 2 we went over a very simple system in which we have a seatbelt warning light, and so we have 3 inputs here. We've got a button inside the seatbelt fastener so it can tell you if the seatbelt is fastened. We have a button inside the ignition to show you when a key is inserted, and then we have a weight sensor, for instance, to show you that there's a person sitting in that seat. Notice that whenever we're interested whenever these inputs are true. So we say, for instance, S being the seatbelt is fastened, we're looking at when S equals 1. When K equals 1 means the key is inserted. And when P equals 1, that means a person is in the seat. So if we were to design a truth table for this, this is actually so simple we don't really need to do a truth table. However, if we were to design it as such, we would say we're interested when the seatbelt is not fastened, because we want the light to come on when the seatbelt is not fastened. So the only time that we'd have an output, S, would be 0. We're also interested in when the key is inserted and a person is in the seat. So we're interested in basically P, when P is true, when K is true, and when S is 0. So that means S is not true. And so if we look here at the circuit, we could see we have K and P are ANDed together, and then S is inverted, because we're interested only when S is not true. And if we look at this formula here, we have P and not S. So if there's a person sitting in the seat and they're not buckled up and the key is in the ignition, that's when you want to send the warning light. So let's look at a example from homework number 4 here. We have, this is actually number 12, I believe, on homework 4. Yes. And what we want to do is convert this into the sum of min terms formulas. So a simple way of doing that is we notice we're interested when our inputs are true, is the way we're looking at this. Similarly to what we had with the seatbelt system, where it said S equals 1. So here it says S equals 1, K equals 1, P equals 1. We're looking at our inputs, whatever they may represent. A equals 1, B equals 1, and C equals 1. So whenever these things whenever we see a 1 in the A column, we can replace that with just A. Whenever we see a 0, 0 is not 1, or 1 inverted. So we would actually put an A naught there. So we have A naught equals 0. Let me put a little space there. And the same thing with our other inputs. We have B naught equals 0 and C naught equals 0. So what we could do is actually go through this truth table and replace all of the zeros in the A column with A naught. All of the 1s in the A column can be replaced with an A. And similarly, we can do the same with columns B and C. Now we're only really interested in the inputs in which our output is true. So to simplify it and make it a little faster, let's only do the 6 cases in which the output is true. So we have this one, this one, this one, we skip one, go to this one, and this one. So I'm going to delete this just for space right now. So again, whenever we have a 0 in the A column, well, maybe I'll put that back real quick until we fill this out. So whenever we have a 0 in the A column, we're going to ignore the first one here because our output is 0. Our first output of being 1 is right here. So when there's a 0 in this column, we're going to replace that 0 with an A naught. So we go A naught. The next one is B as 0. Well, that's actually B naught. That's how you represent it. B being 0. So we would replace that with a B naught. And in column C we have a 1. So we say whenever we have a 1, we're going to just put the variable that it represents. So that's C. The next column, or the next row, where we have an output of 1, A is a 0, so we'll actually replace that with an A naught. B is a 1, so we should replace that with a B. And C is a 0, so when C is equal to 0, we can replace that with the C naught. The next column, again, A is 0, so that becomes an A naught. B is 1, so that becomes a 1, or sorry, a B. And C is 1, and when C is 1, that becomes a C. This next row, we're going to skip that row because our output is 0, and therefore it won't affect our minterms. So the next one that's of consequence here is we have a 1 in the A column. And when there's a 1 in the A column, we can replace that with A. We have a 0 in the B column, so that is B naught. And a 0 in the C column, we could replace that with a C naught. Oops, I did the wrong row there. Oops. So do that. B naught, and then this last one is actually C, so we have a C here. The next row is A. You could probably guess that this is now going to be B, and you can guess that this is C naught. And the last one is A, B, and C. So for each one of these outputs, each of these terms is a minterm, and you can represent this as a single formula. Now for this row, for instance, if this were the first row being after the 0th row, what we have is A naught and B naught and C. And so all of those have to be ANDed together for us to actually get a 1 on this output here. So I'm going to delete this now. So everywhere we have a 1, we're just going to write this formula. So the first one is A naught and B naught and C. And since this is the sum of minterms, or sum of products, this is our product, our first product, and it's going to be added to the next products. And so we look for the next time that we have a 1 as our output, and we will write this product, A naught and B and C naught. And we still have more to do in our table, so we'll go to the next one. This is A naught and B and C. Now something that you should notice is if I were to have filled out these top ones here, where it's just zeros, A naught, B naught, and C naught, and if I were to fill out this one, we have A, B, oops, B naught, sorry, and C naught. If you look at each of these rows, and using our original concept of whatever the input is equals 1, when we have an A naught, we could simply replace that with a 0. And so we have the same pattern that we did with the 1s and 0s in there. So in the least significant bit column, C, we have a, for every row, it inverts from the row previous. So we used to have 0, 1, 0, 1, 0, 1. Here we have C naught, C, C naught, C, C naught, C, and so on. Similarly, with the second column, we have we originally had 0, 0, 1, 1, 0, 0, 1, 1. Here we have B naught, B naught, B, B, B naught, B naught, B, B. And finally, the most significant bit here, we used to have 0, 0, 0, 0, 1, 1, 1, 1. Now we have A naught, A naught, A naught, A naught, 1, 1, 1, 1. So that's important, because you need to double check and make sure that this pattern still exists. Because if it doesn't exist in the correct method anymore, then you need to go back and look at whether or not you've gotten the correct formula in the correct row. So anyway, sorry, back to writing our sum of min terms quickly here. So we've got the first three. We've got A naught, B naught, C, A naught, B naught, C. We've got A naught, B, C naught, A naught, B, C naught. We have A naught, B, C, A naught, B, C. The next one of consequence, we're going to skip this row because it's a 0 on the output. So the next one of consequence here is row number 5. If we start counting at 0, the 0th row being the top. So we'll write this product. We have A, B naught, C. A and B naught and C. And now we'll go to the next row that's of consequence, which is A, B, C naught. So A and B and C naught. And finally we're going to add the last term here, which is A, B, C. So this is how you would go from a formula, or from a truth table, to a sum of min terms formula. Again, we can actually simplify this. You remember we had the other method of representing a sum of min terms equation, sorry. And I'll make another screencast to explain that from this point on, and to fill in a table if you're given either this or the sum of min terms product, the shorthand word version.